Hello everyone. Let's start studying or seeing some practice questions from thermochemistry, which is and we are studying some part 4 questions. So let's start. Disclaimer slide which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@irtk.ac.in and we shall remove the images. Okay, so we have index and we are going to see some practice questions today from question number 38 to question number 45. Okay, let's start with the question number 38. The dissolution of CaCl2.6H2O in large volume of water is endothermic to the extent of 3.5 kilocalorie per mole. For the reaction, CaCl2 plus 6H2O will give you CaCl2.6H2O. Delta H is minus 23.2 kilocalorie. Hence, heat of solution of CaCl2 anhydrous in a large volume of water is. So, options are 26.7 kilocalorie, minus 26.7 kilocalorie, 19.7 kilocalorie, or minus 19.7 kilocalorie. So, you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is C option. So we have given this equation CaCl2 plus 6H2O will give you CaCl2.6H2 in the solid state, right? And del H for this reaction is minus 23.2 kilocalorie, which is given. And CaCl2.6H2O will again, dissolve in the aqueous solution. We have the product as CaCl2.6H2O again. And del H for this reaction is 3.5 kilocalorie, right? Thus, CaCl2 plus aqueous solution in excess will give you CaCl2.6H2O. So, the del H for this reaction will be the sum of these two reactions, right? Because on adding these two reactions, we get this reaction. So, del H will be minus 23.2 plus 3.5. We have this is equals to 19.7 kilocalorie, right? So option C is the correct. Option C is the correct answer. Okay. So let's move to question number 39. The temperature of a bomb calorimeter rises by 1.6 Kelvin when a current of 3.2 ampere is passed for 27 seconds from a 12 volt source. So we have given the temperature rise, the current, the time for which it passed, and the voltage source, right? Which of the following statements is true? Options or statements are the calorimeter constant is 648 joule Kelvin inverse. This calorimeter constant will be same if the calorimeter is open. The information is insufficient for calculating calorimeter constant, or the calorimeter constant is independent of calorimeter content. So you have to choose the true statement among these four statements. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is A option. Q, that is charge, is given by I cross T current into time, and it will be 3.2 multiplied by 27, and energy produced is equal to Q into voltage, so it will be 3.2 multiplied by 27 multiplied by 12, coming out as 1036.8 joule. Okay. So calorimeter constant is given by change in enthalpy in joule divided by change in temperature in Kelvin. And on putting the values, we have calorimeter constant is equal to 648 joule Kelvin inverse. Hence, option A is the correct answer. Okay, let's move to next question. Question number 40. For the complete combustion of ethanol, C2H5OH plus 3O2 will give you 2CO2 plus 3H2O. The amount of heat produced as measured in bomb calorimeter is 1364.47 kilojoule per mole at 25 degrees Celsius. Assuming ideality, the enthalpy of combustion del CH for the reaction will be. So we have to find out the enthalpy of combustion. R is given here 8.314 joule Kelvin inverse mole inverse. Options are minus 1366.95 kilojoule per mole, minus 1361.95 kilojoule per mole, minus 1460.50 kilojoule per mole, or minus 1350.50 or 50 kilojoule per mole. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. This is the reaction given in the question already, and the change or the amount of heat produced as measured in the bomb calorimeter is given as 1364.47 kilojoule per mole. And we know this relation between the internal energy enthalpy change, which is del H is del U plus del NGRT. Del NG here is the gaseous moles changing, which is 2 minus 3, which is minus 1. So del H will be minus 1364.47 plus del Ng minus 1 R value multiplied by T, which is given as 298 divided by 1000. 1000 we are dividing because the value of R is in unit of joule and we want the answer in the kilojoule. So on solving these two, we have del H value as minus 1366.95 kilojoule per mole. Hence, option A is the correct answer. Okay, let's move to next question. Question number 41. The enthalpy of dissolution of BaCl2 and BaCl2.2H2O are minus 20.6 and 8.8 kilojoule per mole respectively. The enthalpy of hydration for this reaction, that is BaCl2 plus 2H2O, will give you BaCl2.2H2O. So we have to find the enthalpy of hydration for BaCl2 following this reaction. Options are 29.4 kilojoule, minus 29.4 kilojoule, minus 11.8 kilojoule, or 38.2 kilojoule. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is B option, which is minus 29.4 kilojoules. So let's see how. So we have this equation. So we have given the enthalpy of dissolution of BaCl2. So BaCl2 is giving Ba2 plus plus 2Cl minus, and del H, which is we can consider H1, is given as minus 20.6 kilojoule for this reaction. Second, the enthalpy of dissolution of BaCl2.2H2O. So BaCl2.2H2O will give you Ba2 plus plus 2Cl minus plus 2H2O. And the del H, or you can say H2 for this reaction, is 8.8 kilojoule. We consider first reaction as first and second as second. And for this reaction given in the question, we have to find the enthalpy of hydration. So for BaCl2 plus 2H2O plus B will give you BaCl2.2H2O. We have to subtract both first and second equation from each other, right? The first minus second. And if you subtract equation first from second, you get the equation given in the question, which is this. And enthalpy will also get subtracted. So the final enthalpy for this reaction, for the final reaction, is del H1 minus del H2. That is enthalpy of first reaction minus enthalpy for second reaction. It is minus 20.6 minus 8.8, right? And on solving, we have the enthalpy for the final reaction as minus 29.4 kilojoule. Hence, option B is the correct answer. Okay. Let's move to the question number 42. The standard enthalpy of formation del H0F at 298 Kelvin for methane is minus 74.8 kilojoule per mole. The addition information required to determine the average energy for CH bond formation would be. So we have to add or give the additional information which is required for the CH bond formation. So options are the dissociation energy of H2 and enthalpy of sublimation of carbon. Right? These are two information. Or latent heat of vaporization of methane. Or the first four ionization energies of carbon and electron gain enthalpy of hydrogen. Or the dissociation energy of hydrogen molecule, that is H2. So we have to choose which is the additional information which we have to or must have to give or have to know for determining the average energy for CH bond formation. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number A, that is the dissociation energy of H2 and enthalpy of sublimation of carbon. So let's see how. The carbon is found in solid state. The state of substance affects the enthalpy change, of course, because solid to gaseous enthalpy is also present. If the reactant is in solid or the product is in solid, the formation of CH4, that is methane, the equation can be written as. So for the formation of CH4, we can write this equation: C plus H2 will give you CH4. And carbon, which is in solid state, have to go in gaseous state of carbon. So enthalpy of sublimation will be using in this conversion or process, and H2 in the gaseous state will go to 2 atoms of H in the gaseous state, and energy of dissociation energy which should be used in this process. These two type of energies are required for the average energy of for determining the average energy of CH bond formation. Hence, option A mentioning these 2 points, which is enthalpy of sublimation and energy dissociation, is the correct answer. Let's move to next question. Question number 43. What will be the enthalpy change for the combustion of cyclopropane at 298 Kelvin? The enthalpies of formation of CO2, H2O and propene are minus 393.5, minus 285.8 and 20.42 kilojoule per mole respectively. The enthalpy of isomerization of cyclopropane to propene is also given, which is minus 33 kilojoule per mole. So we have to find out the enthalpy change for the combustion of cyclopropane. So options are 844.663 kilojoule, minus 844.63 kilojoule, minus 2090.82 kilojoule, or 1893.44 kilojoule. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer for this question is option C, which is minus 2090.82 kilojoule. Right, so let's see how. So we have given that the cyclopropane will go to the enthalpy of formation of CO2 is given, H2 is given, and propene is given, right? So we have the this reaction here, cyclopropane, right, and isomerizing to propene, right? And the enthalpy of isomerization is given as minus 33.0 kilojoule. Let's suppose this is first reaction. Now enthalpy of formation of CO2 is given, so C plus O2 will give you CO2, and del H will be minus 393.5 kilojoule per mole for this reaction, and let's suppose this reaction is second. Now enthalpy of formation of H2 is also given, so H2 plus half of O2 will give you H2O, and enthalpy as given as minus 285.8 kilojoule per mole, and this is, let's suppose, third reaction. and the enthalpy of formation of propene is given. So 3 carbon plus 3 molecules of H2 will give you CH3 CH double bond CH. So that is one molecule of propene. And the enthalpy of formation for this process or for the formation of propene is 20.42, which is given in the question, right? Let's suppose this is fourth reaction. So these all reactions and their enthalpies are given in the question. So we just write them. Okay. Now what we'll do, we subtract equation fourth from equation first, right? So we subtract equation fourth and equation first, right? So our final reaction after subtracting is 3C plus 3H2. It will give you cyclopropane, and the enthalpy will also be subtract from the equation fourth, like equation fourth and equation first reaction. Enthalpies will also get subtracted, and the enthalpy, final enthalpy will be 53.42 kilojoule. And let's suppose this is fifth reaction. Now we have to multiply the equation 2 by 3, plus we have to multiply the equation third by 3, and then subtract it from equation fifth. So final reaction will be propane or cyclopropane plus 9 by 2 of O2 will give you 3 CO2 plus 3 H2. And we have to find the enthalpy for this reaction, for the final this reaction, right? So as we multiply by 3 and add and subtract the equations, similarly their enthalpies will also get multiplied and add and subtracted. So the final enthalpy for this reaction will be 3 times the enthalpy of equation 2 plus 3 times the equation of enthalpy 3 minus the enthalpy of equation fifth. And finally, the final equation enthalpy is coming out as minus 2090.82 kilojoule, right? So this is the final answer for this question. Okay, so let's move to the next question, question number 44. If the bond dissociation energies of XY, X2 and Y2 all are diatomic molecules are in the ratio 1 is to 1 is to 0.5, and the enthalpy of formation for the formation of XY is given as minus 200 kilojoule per mole, the bond dissociation energy of X2 will be, options are 400 kilojoule per mole, 300 kilojoule per mole, 200 kilojoule per mole, or none of the above. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number D. So we have this equation if we consider the formation of XY, right? So half of X2 plus half of Y2 will give you XY. And if you write the equation for the relation between the enthalpy and the bond energy, it will be del H equals to del H for reaction equals to half of bond energy of reactants, that is XX bond, plus half of bond energy of YY bond minus bond energy of XY bond, right? So and we have given the bond energies ratio 1 is to 1 is to 0.5. So let's consider that the bond energy of XY is A. We have given in this order, right? In like first for XY, that is 1, then X2, that is 1, then Y2, that is 0.5. So if we consider the bond energy of XY as A, so the bond energy of XX will also become A because it is in 1:1. And the bond energy of Y2 will become A by 2 half, which is 0 because it is in the ratio 0.5, right? So A by 2 for XY, XX and YY respectively, right? Now we know the enthalpy of formation for XY bond or XY molecule. So the enthalpy of formation for XY molecule is given as 200 kilojoule or minus 200 kilojoule, which is given in the question. On putting these values in the equation Here in this equation, we have on the left hand side minus 200 equals to the bond energy of XX bond, which is half of A, plus half of bond energy of YY bond, which is A by 2 into 2, because half of A by 2, right? And minus bond energy of XY bond, which is A, so minus A. Now on solving this equation, we have minus 200 equal to minus A by 4. Minus minus will get cancelled and A will be coming out as plus 800 kilojoule. So the bond dissociation energy of X2 molecule is 800 kilojoule per mole. Hence, 800 is not given in the options. Hence, option D is the correct answer. That is none of the above. Right? Let's move to the next question. Question number 45. So 1 liter sample of mixture of CH4 and O2 measured at 25 degrees Celsius and 740 torr was allowed to react at constant pressure in a calorimeter. Together with its contents had a heat capacity of 1260 Kelvin inverse. The complete combustion of CH4 to CO2 and water caused a temperature rise in calorimeter of 0.667 Kelvin. What will be the mole percent of CH4 in the original mixture? Heat of combustion of CH4 is given as minus 215 kilocalorie per mole, and options are 25%, 15%, 40%, or 10%. Here it is mole inverse. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is D option, which is 15%. Oh, sorry, 10%. Right? Correct answer is D option, 10%. So let's see how. Heat generator is given by C multiplied by del T. T is 1260, and del T, that is temperature rise, is 0.667 Kelvin. It is coming out as 840.4 calorie. Molar mass of CH4 is 16 gram per mole, and enthalpy of combustion for 16 gram CH4 is given as minus 215 kilocalorie per mole, which if we write in calorie, it is minus 215000 calorie per mole. Thus, the enthalpy equal to minus 840.42 calorie for 16 upon this multiplied by 840.42, which is equals to 0.0625 gram of CH4. Right? So first, we know that 16 gram of CH4, the enthalpy of combustion will be this. And if we know the enthalpy of combustion, so we can find out the mass of CH4, which is coming out as this. So the number of moles of CH4 in the reaction will be the mass which we have calculated divided by the molar mass, which is 3.91 into 10 to the power minus 3 mole. Now we apply this ideal gas equation, PV equals to nRT, putting all the values given in the question. N is coming out as 3.92 multiplied by 10 to the power minus 2 mole. So mole percent of CH4 is 3.91 multiplied by 10 to the power minus 3 divided by 3.92 into 10 to the power minus 2 into 100 for the percentage term. So it is coming out as 9.97 approximate to 10%. Hence option D, which is 10%, is the correct answer for this question. Okay. Thank you.